partial fraction decomposition. All right, before you guys are like, oh my gosh, let's think about what this means. What does it mean if something decomposes? It breaks down, okay? Partial. If you get partial credit versus full credit. Some of it, pieces, okay? And everyone in here knows what a fraction is. So all partial fraction decomposition is, it says it's the sum, it's the sum of two fractions. So if you notice here, do you guys see the equal sign? Right here. Everybody see the equal sign in the middle here? So I have this piece on the left, and then I have these two pieces on the right. Those two are equivalent, and I'll show you how to check that in a second. But what we're going to do is we're going to take a big rational function, right? A rational function is just a grown-up fraction, and we're going to decompose it. We're going to pull it apart. This is heavy on the algebra, but this is not a difficult concept, I promise you, and I'll show you how to check it. It is a tad lengthy at times, so don't get frustrated, but all we're doing is taking a large rational function, and we're decomposing it. We're breaking it down. It's always the sum, and I'll show you because sometimes this sign in the middle changes. Like right here, plus a negative is the same as what? Subtraction, right? So you could write it as a subtraction, but it's just so you don't get yourself confused on when do I subtract, when do I add. It's always the sum of the fractions. Just one of them might be negative or two of them might be negative. All right, this is the book. Right? This is the book telling you how to do it. When you decompose, you're going to have a constant in the numerator. That's just a plain number. And then a linear factor in the denominator. What does it mean if it's a linear factor? What is your x value raised to? The first power. All right? So, if you notice here, if this were multiplied all together, it would be a cubic, right? Because there's three x's. So when you partially decompose, you're taking the entire fraction and breaking it into pieces. Each part of your decomposition will have one linear factor in the denominator. However many pieces you have, that's how many different fractions you have. And we just use capital letters, A, B, C, D, and so forth. Okay? Your final answer will be this with constants for your A, B, and C. And then I'll show you how to check that stuff. So here's what we're going to do. The first thing you're going to do is always factor the denominator. Sometimes it's factored for you, sometimes it's not. Then we're going to split the fractions for each term in the denominator. If there's three terms in the denominator, you have three fractions. And you name them, A, B, C, and so forth. Then we're going to create an equivalent equation. We're going to balance the equation. I'll show you what I mean. Then we're going to solve the denominator, figure out what x values we use, and then we're going to plug in. I'll show you how simple it is, I promise. All right, so here's a problem. First thing you do is factor the denominator. Is the denominator factored already? Yes. All right, if it wasn't, you would factor it. I like to do this step first. You don't have to, but I like to do this step first. I like to solve. What are my x values that I'm going to use to evaluate here? If I solve my denominator, I say x minus 3 equals 0. What am I going to plug in? X equals positive 3, and x equals what? Negative 5, okay? We're going to save that for later. We're going to use that. So what we're going to do now is we're going to decompose. We're going to break our big fraction apart. How many linear factors are in your denominator? 2. So you have 2 fractions. I'm going to use x minus 3 first and x plus 5 second. Could you have written them the other way? Absolutely. Totally up to you. Your answer will work itself out. However many different pieces you have, those are the letters you use. So I'm going to use a capital A and a capital B. Now, I put an equal sign there, so I'm telling you that the left-hand side is equal to the right-hand side. It is not right now, but we can make it equivalent. Look at fraction A. It has the x minus 3 in the denominator. What is it missing? If the left-hand side is going to equal the right, it has the x minus 3. What is it missing? Guys, if you're going to make an equivalent, you want the left-hand side to be the same as the right. If you have the x minus 3, what's the other piece of the denominator that it's missing to be the same? X plus 5. What you do to the bottom, you do where? To the top, okay? The second fraction has the x plus 5. What's it missing? X minus 3. So I have to multiply the bottom by x minus 3, then I multiply the top by x minus 3. What do you notice now about the denominators on either side of the equal sign? They're the same. You can just cross them off. You don't have to worry about them anymore. All right, they're not in your brain anymore. What is in your brain is the numerator of both sides. You just made an equation that says 6x plus 14 equals a times x plus 5 plus b times x minus 3. And we're going to solve that equation 2 times. We're going to find our a value, and we're going to find our b value. And we already know what we're going to evaluate with. What are the 2 x values that we're going to evaluate with? X equals 3, and x equals negative 5. So x equals 3, and x equals negative 5. Now, every single time you do this process, the same thing will happen, and you'll see here in a second. But if I evaluate this, so I have 6 times 3. There's lots of work to show here. I'm not going to have room. Hold on. 6 times 3 plus 14 equals a times 3 plus 5, right? Plus b times 3 minus 3. Everybody with me? Yeah. Okay, so let's simplify. What's 6 times 3? 18, and then 18 plus 14 is 32. Okay, keep going. Inside my parentheses, what is 3 plus 5? 8. So do you guys agree with me this just becomes 8a? And then what happens with 3 minus 3? 0. And then what's 0 times b? 0. So this just does what? It cancels out. So now you can solve for a. Divide both sides by 8. And a equals what? What's 32 divided by 8? 4. Okay. All right, good. All right, you found your a. Now we're going to do the exact same thing on the right-hand side, but we're going to evaluate using what number? Negative 5. So 6 times negative 5 plus 14 equals a times negative 5 plus 5 plus b times negative 5 minus 3. So let's simplify. What's 6 times negative 5? Negative 30 plus 14 gives me, what kind of 16? Negative 16, okay? Equals, well guys, what happens with negative 5 and positive 5? 0, and then 0 times a is, so what happens? This cancels out. With my b term, what's negative 5 minus 3? So I have negative 8b. Divide both sides by negative 8, and what does b equal? b equals 2. Every single time, whether you have 2 denominators, 3 denominators, 4, every single time, when you evaluate, everything will cancel out except for one thing. If it doesn't, you did something wrong. So what we have done is we have now discovered what the constants are in our partial fraction decomposition. So you're going to go back to your original. Instead of a, you're going to write the number 4, right? Over, what was the denominator you had with a? X minus 3. Plus, my b term was 2. What's the denominator you had with b? X plus 5. Now, if you wrote your x plus 5 first and x minus 3 second, that's fine. You just would have had 2 over x plus 5 plus 4 over x minus 3. That is your answer. This is your partial fraction decomposition. You took this original and you broke it down. Now, some of you love to check your work, which is fantastic. Let me show you how. If you were going to add these 2 fractions together, how do you add fractions? You have to have a what? My common denominator between x minus 3 and x plus 5, would you agree, is just x minus 3 times x plus 5, right? So my 4, in the numerator, I have 4. It has the x minus 3. What is it missing? The x plus 5, okay. My second fraction, 2, in the denominator has the x plus 5. What is it missing? X minus 3, okay. So if I distribute here, I have 4x plus 20 plus 2x minus 6. Agreed? Yeah? So if we simplify, what's 4x and 2x? 6x. And what's 20 minus 6? 14 over x minus 3, x plus 5. What did you guys start with? 6x plus 14 over x minus 3x plus 5. Same thing. So you just proved to yourself that they were equivalent. All we're doing, guys, there's a lot of algebra behind it, but you're just breaking it down, solving for your a and b, and then plugging it back in. I'll show you some things that might arise with fractions and stuff like that. We'll talk about that in a minute, but let's just do, I have 2 more problems I want to just do with you to kind of get the hang of it. All right, we okay? All right, let's go to the next one. All right, again, this is already factored for you. It's not generally going to be like that. You have to factor it, but no big deal. The first thing I like to do is say, okay, well, when I evaluate, what are the 2 numbers that I'm going to evaluate with? In this case, they're going to be what? 2 and, okay, perfect. So now I have to say, all right, I have to get I need to make an equation here. I'm going to take my whole fraction, I'm going to decompose it, I'm going to break it down. So what are the 2 denominators that I'm going to break it down into? What are my 2 denominators? X minus 2 and x minus 5. Some of you might write x minus 5 first and x minus 2 second. That's fine, doesn't matter. Each fraction gets a letter, so start with A. This is going to be A, this is going to be B. All right? Right now, I have an equal sign that I'm telling you the left-hand side is the same as the right. Is it right now? No. So what do I have to do? I have to get a common denominator. So if I want to get a common denominator here, what would I have to multiply my A fraction by? X minus 5, right? What you do to the bottom, you do to the top. B needs x minus 2. So what you do to the bottom, you do to the top. Now, are they equivalent? Is everything the same? It's balanced? Denominators are all the same on both sides? Yes. So your equation that you're going to evaluate with is x minus 14 equals A times x minus 5 plus B times x minus 2. Now, every time you plug in an x value, what should happen to one of your constants? They should cancel. So I'm going to evaluate here, the first one with x equals 2. If you want to do x equals 5 first, fine, doesn't matter. So I have 2 minus 14 equals A times 2 minus 5 plus B times 2 minus 2. There's lots of places during this process that you can check to make sure you're on the right track. This is one of those checkpoints. What's 2 minus 14? Negative 12. Okay, equals, what's 2 minus 5? So this is negative 3a. What's 2 minus 2? 0. So what's going to happen here? This is going to cancel. That should always happen. If you get another number there, then you did something wrong. You missed a sign. Now I'm going to divide both sides by negative 3. So what is my a term? What's my a constant? What's negative 12 divided by negative 3? Okay, 4. Perfect. So let's do the same thing, but now I'm going to evaluate on this side with x equals what? 5? Okay, so I have 5 minus 14 equals A times 5 minus 5 plus B times 5 minus 2. So guys, on the left, or on the left-hand side of the equal sign, what is 5 minus 14? Negative 9, okay, equals, what's 5 minus 5? 0. What's going to happen with A here? Cancels out. Good, we're on the right track. What is 5 minus 2? So I have 3b, divide both sides by 3, and what does b equal? Negative 3. Good. So I now have broken down my 2 fractions. I broke it down into 2 fractions, and I found my constants that go on top of them. So now we write our partial fraction decomposition. I have 4 over x minus 2 plus negative 3 over x minus 5. Now, if you want to, could you also write this as 4 over x minus 2 minus 3 over x minus 5? Is that the same thing, plus a negative or minus? Yes or no? Yeah, absolutely, you could do that. Some of you, if you did x minus 5 first, yours says negative 3 over x minus 5 plus 4 over x minus 2. The order doesn't matter as long as the correct constant is with the correct denominator and the signs are right. So either one of these is a correct answer. If you have plus and negative, I'm fine with that. Or if you actually want to say minus, that's fine. And then how would we check it? Just to make sure, Well, what's a common denominator between x minus 2 and x minus 5? Both of them together, right? So my first denominator has the x minus 2. It's missing the x minus 5. Plus the second denominator has the x minus 5. It's missing the x minus 2, right? So 4x minus 20 minus 3x plus 6. What's 4x minus 3x? X. What's negative 20 plus 6? Minus 14. Is that what we started with? Up here? Yes. So you're good to go. Again, you don't have to check it if you don't want to. I'm just showing you that you can check all of your work. On WebAssign, I believe the questions that we assigned you, because some of them are really hard to input on WebAssign, I believe all they're asking you to do is just this part, just the setup with the A and the B, breaking it up. But on the quiz, you're going to have to solve it. But I think on WebAssign, all we did was just give you ones that you just have to set up. All right, everybody okay? All right, let's do one more. This next one's long. Don't get frustrated. What's the first step? What do we have to do? Factor the denominator. Do you guys agree with me? I can take out an x, and then I'm left with x squared minus 4. Yes, which is the same as x plus 2, x minus 2. Okay. Right, so I got the x, you're left with x squared, the difference of perfect squares. So in this case, I'm going to evaluate, how many times? 3. I'm going to evaluate with x equals 0, x equals negative 2, and x equals positive 2. This is where we just have to make sure that we stay organized. That's it. We're going to use those values later. So how many different linear factors do I have in my denominator this time? I have 3. So that means I have 3 fractions. Again, it does not matter the order that you put your fraction. I'm just going to say one denominator is x, one is x minus 2, and one is x plus 2. The letters I'm going to use would be A, B, and C. So now we're going to do this 3 times. What should happen each time I evaluate? How many variables should cancel out? 2. Good. So now we have to make each side of the equation balanced. A has the x. What is it missing? X minus 2 and x plus 2. So I'm just going to write that as x squared minus 4. B has the x minus 2. What's it missing? X and x plus 2. C has x plus 2. What's it missing? X and x minus 2. Questions so far? All right, you guys are doing great. Now we're going to evaluate how many times? 3. So I'm going to go here and here. This one looks a little long, but it's okay. You're fine. So I have x squared, so 0 squared, right, plus 12 times 0 plus 12 equals a times 0 squared minus 4 plus b times, what did I do for b? Plus 2. So 0 times 0 plus 2 plus c is 0 times 0 minus 2. Everybody agree with what I wrote? Okay, so if we evaluate, what's 0 squared? 0. And then what's 12 times 0? 0. So what am I left with on the left-hand side? 12. Okay, equals. What is 0 squared minus 4? So I have negative 4a, right? And what happens when I add 0 plus 2 and times it by 0? It cancels. What happens when I subtract 0 minus 2 and times it by 0? It cancels. So divide both sides by negative 4. And what is your a value, guys? What is it? Negative 3. Perfect. Again, a lot of writing, yes. But the math behind this is not real hard. You just got to be super careful. You guys cannot make little mistakes. Little mistakes make big impacts on problems. So now I'm going to evaluate. I used 0, so now I'm going to use negative 2. So I got to write small. So I have negative 2 squared. Is it minus or plus? Plus 12 times negative 2 plus 12, right? Equals, A is negative 2 squared minus 4 plus b is negative 2 times, what was b? Why b? X plus 2. So negative 2 plus 2, right, with the way I wrote it? Yeah. And then my c is negative 2 times negative 2 minus 2, right? Guys, yes? Right, thank you, Ava. I'm trying to write small, and then I wrote minuscule. All right, so if we evaluate, guys, negative 2 squared is 4, right? What's 12 times negative 2? Negative 24, good, plus 12. Keep simplifying the left-hand side. What's 4 minus 24? Negative 20 plus 12 gives you negative 8, okay? Now let's go to the right. Negative 2 squared is 4. 4 minus 4 is gone. Negative 2 plus 2 is 0 times negative 2, gone. God bless. What's negative 2 minus 2? Negative 4, and then negative 4 times negative 2 is 8. So I have 8C. Does it matter that this time we solve for C? No, it doesn't matter. Just make sure you write C equals. So I divide both sides by 8, and I get C equals what? C equals negative 1. Okay, so I know my A term. I know my C term. Now I'm going to find what? The B, whatever. So I evaluated already with x equals 0. I evaluated with x equals negative 2. So now I'm going to evaluate with x equals positive 2. So we go back to the beginning. I have 2 squared plus 12 times 2 plus 12 equals a times 2 squared minus 4 plus b times 2 times 2 plus 2 plus c times 2 times 2 minus 2, right? Okay, so evaluate the left. 2 squared is 4 plus 12 times 2 is 24 plus 12. What's 4 plus 24? 28 plus 12 gives you 40, okay? 2 squared, 4. 4 minus 4 is gone. 2 plus 2 in the middle here. 4. 4 times 2 is 8. So I have 8. God bless you, B. And then what happens over here? 2 minus 2 is 0. 0 times gone. Do you see how every single time, guys, 2 of the 3 canceled? That'll always happen. So you divide both sides now by 8. And this is the longest problem in the entire world, but B equals what? 5. Is that our answer? No, we did a whole bunch of work, but you are asked to find the partial fraction decomposition. That means when you decompose, when you break this big left-hand side rational down, what does it look like? Well, your A term was how much? A was negative 3, so I have negative 3 over x plus, what was your B term? 5, so 5 over x minus 2 plus, what was C? Negative 1 over x plus 2. What's another way I could have written that negative 1 over x plus 2? You could have said minus 1. If you guys wrote your denominators in a different order, maybe you had x plus 2 before x minus 2, that's fine. Just as long as x plus 2 has a negative 1 in the numerator. Just as long as x minus 2 has a 5 in the numerator. The order doesn't matter. As long as the numbers are with the denominators you assigned from the beginning, and the signs are correct. Now again, you could check this one. How would you have to do it? You'd have to get a common denominator and kind of work backwards like we just did. I'm not going to do that because it works. But I want you guys to know that you can always check these problems. All right, are these awful? Yes. They're a pain, I know that, but it's not terrible. 2 things I want to bring to your attention because you're going to see it on WebAssign and you might see it on your quiz. Say you came out with, you had A and then, I don't know, 3x plus 1 plus b x minus 7, right? Whatever, that partial fraction decomposition. And you guys found out that a was 3 over 11 and b was negative 5 over 11, all right? That's a fraction. That's fine. So you would write it and you would say 3 over 11 divided by, whoops, 3x plus 1. And then I have plus negative 5 over 11 over x minus 7. Does that look simplified to you? No. All right, let me show you how easy this is to do. This is not a big deal. If I were to simplify 3 over 11 divided by 3x plus 1, this is over 1, right? So if I keep change flip, I would have 3 over 11 times 1 over 3x plus 1, correct? So when we multiplied this, you'd have 3 over 11 times 3x plus 1. Guys, if you have a fraction, where does the denominator of that number go? When we just did keep change flip, what does it look like? So what do you do with the 11? No, when I'm at this step, when you guys get here, you can't leave it like that. That's not okay. So how would you rewrite it? Where would the 11 go? Where is the 11 here? Okay, what I'm getting at is if you guys left your answer like this, that's wrong. The correct way to write this would be 3 over 11 times 3x plus 1 plus, or a negative if you want, negative 5 over 11 times x minus 7. But do you see why that 11 just goes in the front of the denominator? I just showed you why mathematically here. If you keep change flip, do you guys understand what I'm saying? So if you end up with a fraction, whatever the numerator is of your a or your b or your c, just stick it in front of the denominator. That's it. But the reason why you do that is because of dividing fractions. Keep change flip. Now, another thing I want to bring to your attention. Say you have x plus 7, whatever, over x minus 2 cubed. You might have to set these up, but you will never have to solve one like this because it just takes too long. What does x minus 2 cubed really look like? What does that mean? X minus 2, what? X minus 2 and x minus 2. All right, this is a special case. In order for this to mathematically work out correctly, right, you have how many different pieces? 3, agreed. Okay, so you have A, B, and C. This is the farthest you'll have to go with a question like this is just setting it up. If you have the same linear factor, quantity squared, quantity cubed, quantity to the fourth, you start with the first power. The second denominator would be x minus 2 squared. The third denominator would be x minus 2 cubed. If it was to the fourth power, you'd have 4 pieces, and it would go x minus 2 squared, x minus 2 cubed, x minus 2 to the fourth power. Whenever it's a quantity raised to a power, you just start with to the first power, and you should end with whatever's in the problem. I am not going to have you work this out because this one problem could take you 20 minutes. That's just crazy. But to understand the setup is what I want you to do. Whenever it's the same quantity, squared, cubed to the fourth, whatever, you just write out in ascending order. So this is first, this is second, third. If it's the fourth, it goes to the fourth. Does that make sense? Just in case you guys see that. All right, that is it.